Okay, we're going over section 1.10 today, which is mathematical modeling. So we're going to look at how to model various scatter plots with linear regression, and we're going to go over direct variation and indirect variation equations. Okay, so let's start with example 1, where we're talking about population that grows over various years. Okay, and we're given the equation y equals 2.78t plus 282.5. Okay, so t is going to represent our year and y is going to represent our population. And we're going to graph both our scatter plot and our line to figure out how close they are. So if you turn on your calculator and you go to your stat button, it's next to the X button. And then you'll see edit pops up on number 1, so we're going to edit. And then in list 1, we're going to put all of these data points, except we're not putting them as 2000. We're using like 0, 1, 2, 3, 4. Okay, what mark? No, just put it in your calculator. Yep. Okay, and then put your population into list 2. So you'll just go over and then you'll put your population in next to it. Okay, once those are in, then you go to your y equals button and you go up above y equals where it says plot 1 and you push enter so that plot 1 is highlighted. And then also type in that equation into your y equals. Then you go to your y equals button and you go up to where it says plot 1 and you highlight that, so hit enter. And then you type in that equation into your y equals. Okay, then hit graph, and likely nothing will show up on your screen because of how large the numbers are. So we're going to hit our zoom button and go down to 0 where it says zoom fit, and we're going to select that. And then hit enter. Okay, so then you should get a graph and you should get various dots on your screen. The dots is the information from the table and the line is the equation of the line, and we want to figure out how that best fits. So we're going to describe our best fit. So we're just describing, do we think the line fits those scatter points or does it not fit those scatter points very well? Okay, seems to fit. So when it asks you if it fits, that's all you have to do is tell me whether it fits or not. We're also going to look at finding various lines using this information. Okay, so if we look at our second table, we have years and debt. And so go ahead and go back to your stat edit and edit that list to fit this data. You leave your years the way it is, so 0, 1, 2, 3, 4, 5, 6, and then your debt would go into list 2. Okay, so once it's in our list, then we need to figure out whether or not we can find a line of best fit. So you'll exit out of your list and then you'll hit your stat button again. Oh, just hit delete. And then just wait. Oh, sorry, hit that delete button, it's not clear. And then it works. Okay, so once they're in there and you go back to your stat button, then you go over to Calc. So you'll push over to Calc, and then you go down to number 4 where it says linear regression. We're going to figure out what our linear regression is. Yep, ax plus b. Then a screen will pop up that says x list, y list, and everything should be filled in for you. So all you have to do is go down to calculate and hit enter. Okay, so then it tells us that we're going to have an equation in the form y equals ax plus b. And it gives us our a and b. So in this case, our a is 1, so y equals 1x plus our b is a very long number that I'm going to round to 2 decimal places, so 6.71. Okay, so just round your b off. You didn't get that? Wow. Oh, I bet it's because these are... I think it's because you use 2000 instead of like 0, 1, 2. There you go. Okay. Let me see. Yes, you're supposed to use 1 or 0, 1, 2. That's why that's screwed up. Yep, that's what you're supposed to get. So for the years, only use the last digit. So 0, 1, 2, 3, etc. all the way down. Otherwise, you'll get something like negative 1993 is your b value, and that's not what you want. Okay, so once you've got that, then go ahead and put that equation into your y equals so we can figure out if the line fits. Okay, we want to figure out if this is the line of best fit. And make sure that your plot 1 should still be on, but double check that. It's on if it's highlighted in black. Okay, so does our line fit? Oh, your zoom might be off too. You have to go to zoom and then go to 6 standard. Zoom and then 6 standard, and then it'll show you your graph. Okay. Yay. Okay, did everybody get that? Yeah. Okay. All right, let's do that one more time. So we're going to talk about year and price. So go back to stat and then go to edit so you can get to your list. On years, use 0, 1, 2, 3, 4, and 5. And then plug in the price into the second one. work. Okay, so let's figure out our linear regression. So once you've got that in your list, then exit out of your list and go back to your stat screen. Go over to calculate and down to number 4, linear regression. Okay, and then it should pop up y equals ax plus b, and it gives us an a of approximately 3.78 x, and it gives us a b of approximately 46.76. Okay, is that what everybody got approximately? Okay, so let's plug that into our y equals screen so that we can compare this line to our graph. Okay, and then once you've hit your graph button, you've got that into your y equals and you've hit graph, then go to zoom and hit your 0 button so that it'll go to zoom fit. Okay, because this isn't going to be on the screen since they're such big numbers. So go to zoom and then go to 0, zoom fit. And then once we've got there, does our line fit our graph? Yes. Okay, so that's the first part of what we're doing. That's called determining linear regression. So we're going to go ahead and determine our linear regression. That's the first part. Second part we're going to look at is direct variation and indirect variation, okay? Also known as inverse variation sometimes. So direct variation is either the formula y equals kx or y equals kx squared for some constant k. And inverse variation is very similar. It's y equals k over x for some variation k. Okay, so let's actually look at an example of a direct variation. So we're finding out our tax, okay? So it says in Pennsylvania, the state income tax is directly proportional, so it's a direct variation to gross income. You're working in Pennsylvania and your state income tax deduction is $46.05, so $46.05. That's your tax deduction. And then it tells us for a gross income of $1,500. So equals K times my income of $1,500. And we want to figure out our K so that we can figure out what our direct variation formula would be. Perfect, so we're going to get K by itself. So we need to get rid of this times 1,500, so how are we going to do that? Divide by 1,500 on each side. Okay, and so what is 46.05 divided by 1500 to 3 decimal places? Let's go to 3 decimal places on this one. 0.31 or 0.031. Okay, so we get our k is approximately 0.031 when you divide 46.05 divided by 1500. Okay, and so then we're going to put that into our direct variation formula, y equals kx. So if I do that and I plug in my k, then I know that my income tax formula is going to be y equals 0.031x. So that would be my income tax formula if I lived in Pennsylvania. Okay, so let's do another one like that. We're talking about interest and principal. So a company has found that okay, the simple interest on an investment is directly proportional to the amount of the investment. By investing $2,500 in a certain bond, so $2,500 is my principal, I get an interest payment of $187.50. So $187.50. Okay, so let's solve this for k. Okay, so we need to divide by 2,500 and divide by 2,500. Okay, and so to 3 decimal places, what is my k equal to?
0.
Okay, so 0.075. So that tells me then that for my formula y equals kx, that for this particular situation, it's going to be y equals 0.075x. So for that particular investment, that would be my formula. Okay, so let's look at inverse variations then. So an inverse variation is y equals k over x for some constant k. So if we look at our first one, a gas law states that the volume of enclosed gas varies directly to the temperature and inversely as the pressure. So the pressure of a gas is 0.75 kilograms per square centimeter, while the temperature is 294 Kelvin. And the volume is 8,000 cubic centimeters. Okay, so my volume is 8,000 cubic centimeters. I don't know my K. My pressure was 0.75, and my temperature was 294. Okay, so this is like 8,000 equals 294 K divided by 0.75. Okay, so then to get rid of this fraction, we need to multiply by my reciprocal. So 0.75 over 294 times 0.75 over 294, so that those will cancel. This is like 8,000 over 1, so we can just multiply straight across. So what's 0.75 times 8,000? 4,000. Really? Make it 6,000. 6,000. Okay. 6,000. And 294 times 1 is 294. So once we divide that 6,000 divided by 294, what are we going to get? Okay, so I get k equals 20.41, which then tells me that my equation y equals k over x actually simplifies to y equals 20.41 over x. So that would be my inverse equation for when I'm talking about pressure and gas. Okay, so let's do one more and then we can get started. Alright, so it says, a company has found that the demand for its product varies inversely as the price of the product. When the price is $2.75, so K over 275, then the demand is 600 units. So we need to figure out what my K is. So my demand is 600 units. Okay. So to get rid of division, we multiply. So multiply by 2.75. And what's 2.75 times 600? 1,650. Okay, so my K is 1,650, which then tells me my equation y equals K over X is actually y equals 1650 over X. So this would be my inverse equation for that company and its product. Okay, so you guys are going to work through a couple of problems today. Page 108, 1 through 12, and 23 through 34.